let me start from where I left in the last class, right? So, see here, today I'll start. Hope in the last class I completed some basic definitions like amplitude, wavelength, and all, right? Then thereafter, the very important equation, progressive wave equation, also I have completed, and bit about that if wave travels in negative direction and progressive equation in starting some initial pace. Regarding that, I completed in the last class. Now I'll start today class. Here, let me define first phase. What is phase of a wave? Phase of a wave. See here. We for we know this progressive wave equation, a sine omega t minus kx. I'll take initial phase as 0, right? Okay. This term we call it is phase. Phase. Here phase we write as omega t minus kx. This is phase. Then what do you mean by phase? Phase is that quantity which tells you complete detail of the wave. So at what distance, which particle, vibrating, vibrating, and what is the displacement of that particle at any instant of time. Phase tells you complete information about the wave. Let me tell you, for example, see, this is the wave. This is the wave, right or not? Okay. This is wave. Wave is moving like that with some velocity v. I want to know information about this particle. This particle. I want to know information about this particle. Then phase will tell you where this particle is, where this, then how far that particle is from the mean position, and even that phase will tell you that this particle is moving upward or downward. So what is phase? Phase gives you information about any particle which are at a distance of any particle. Suppose you want to know x distance away from the origin, x distance away from this particular particle P, where it is, how much away from the mean position, y distance away from the mean position, right or not? And even not only y, not only that position of the particle with respect to mean position, even you will come to know the direction of motion of that particle, whether it is going up. It means phase gives you at a chosen x distance away, right? That particle is how far away from the mean position and in which direction at that point of time. Like at any time t, I'm looking at the particle P at a distance x away from the origin reference. So phase gives you complete idea about, so at a x distance away at a particular time t, that particle P is where, how away, how above from the mean position, and at that point it is moving in which direction. Hope you got my point. What I'm saying, phase, it is a physical quantity. It is a quantity which gives information about, complete information about, complete information about wave at any instant, and for any position, for a given whichever position you take, like I mean x here, for a given position, right? This is phase. Let me tell you, phase I told you is what? Omega t minus kx. Okay, fix the x. At a particular x, I want a p particle of the rope. You can say this is a rope. That as k is a 2 pi by lambda. For a given wave, lambda will be constant. What is k here? K is what? 2 pi by lambda, propagation constant. Anyhow, for a given wave, lambda will be constant. Therefore, this complete quantity, I am fixing it constant. Then I am talking about this p particle because I defined x. I am talking about this particle p. So at the time increases, omega, as the time increases, the phase of that particle also changes. Like when the particle is here, completely at amplitude distance away, its phase will be pi by 2. When it comes back, phase is pi. When it goes here, its phase is 3 pi by 2. When it again back to origin, phase will be 2 pi. Again goes that side, 2 pi plus pi by 2. Again comes here, 2 pi plus pi. So as you put the t here, t value, you will come to know angle. Put x value like 2 meter away, you take the time value, at what time you want its phase, you will get phase like 2 pi, 3 pi, 4 pi, like n plus whatever, like angle you will get, and that angle will tell you where that particle is. Hope you are getting my point. So in that regard, already you learned, I don't want to go inside. So if you know phase, you can get to know, so at x distance away, which direction that particle is moving and how far away from the mean position, how far away, why, you will come to know, the direction of motion you will come to know at a particular x. Complete detail of this phase will give you complete detail of the wave, right? Okay, I'll move on. Now let me take particle velocity and wave velocity. Particle velocity and wave velocity. Particle velocity and wave velocity. Both are different here. Particle velocity, you want to know, if this is a wave here, this is the wave velocity. Particle, take any one particle. This particle is oscillating between this place, this distance, this particle is oscillating. The velocity of this particle is different than velocity of wave. Well, you want to know velocity of particle of the medium, we use this formula, a sin omega t minus kx. You want to know velocity of any particular particle which is vibrating simple harmonically, just differentiate it, then you will get velocity of the particle. So A, we are differentiating, with respect to time, therefore coefficient of time is omega, so differentiation of sign is cos omega t minus, since here x is constant. At a particular x, I want the p particle velocity because x is constant for p. So this is what the expression for particle velocity. It is, very clearly indicates here, velocity of particle is a function, is a cosine function. Velocity of particle depends on cos of the function. Therefore, as cos value changes from 0 to 1, 1 to 0, like that, ultimately even particle velocity also changes. This particle velocity also changes, not constant. So therefore particle velocity, changes. How it is changes? Because it depends on cos. Sinusoidally, it means simple harmonically. The velocity of the particle oscillate simple. As it is simple harmonic motion, no, all the knowledge of simple harmonic motion you have to apply here. So here velocity of particle changes simple harmonically, simple harmonically, right, changes. But velocity of wave, it depends on medium. Velocity of wave will remain constant for a given medium. Velocity of wave remain in a given medium, like in a water. At every place the speed of the wave will be same. It depends on the medium. So at different medium the velocity of the wave will be different. So therefore I could say at a given medium velocity of wave remain constant. This velocity of wave remain constant, for a given medium, right or not? Therefore particle velocity changes, so particle of the medium velocity changes, but velocity of the wave will go with constant speed in a given medium. It is a medium dependent. For a given medium velocity of wave will remain same, right? Okay, so this is regarding particle velocity and wave velocity. Now we will see speed of transverse wave in a stretched string. Speed of transverse wave in a stretched string. Right? Speed of transverse wave in a stretched string. Speed of transverse wave in a stretched string. Speed of transverse wave in a stretched string, right? Okay, see here to a rigid surface, one thread is connected and it is passed over the pulley, right? It is passed over the pulley. This thread is passed over the pulley and here some mass has been connected. Remember, if this string is, if weight is more, the string taut very tight, right or not? Then if this string is taut very tightly, then ultimately tension in the string will increase. You can take string connected to wall and one end you hold it and tight you make it, then you create a pulse. Then speed of wave going in that string will be more, right or not? If weight is more, then this tension in the string will be more. As tension in the string will be more, just you pluck it here, then what? The wave will create, transverse wave will create there, and that transverse wave, this transverse wave will go with speed. If this string is tightly, connected, then ultimately when you pluck here, suddenly the speed of the wave will be more. Are you getting my point? More the tension, more tightly that spring is taut here, connected here, then ultimately the tension is more, pluck it here, suddenly wave will move. Are you getting my point? Therefore, velocity of this string is velocity of the transverse wave in the string is directly proportional to tension. More tightly it is connected, velocity will be more. And secondly, the density, inertial factor. If the linear density, heaviness of the string is more, then it will oscillate slowly. Then it will reduce the velocity of the wave. So very clear, velocity of wave is inversely proportional to small m. Let me say, what is small m here? Linear mass density. What is this? Is linear mass density. Linear mass density means what? Mass per unit total mass of string divided by length of the string. I mean heaviness of this string. Heaviness, mass of the string will be more. Then ultimately it can obstruct more to the, it can, this is an inertial factor. More the mass per unit length, speed of the wave will be less because it will slowly oscillate. The string will oscillate slowly, right or not? So by combining these two factors, I could say here velocity is proportional to tension and inversely proportional to linear density. Like that we have made it. Then finally, that proportionality constant has been found out experimentally 1. Proportionality constant found out experimentally 1. So C comes to be 1 experimentally, right or not? Experimentally, right? Therefore, velocity of transverse wave in a stretched string will be T by linear density of the string. But thing is there, any equation we have in physics, it must be dimensionally correct. It must be dimensionally correct. But you take into account the dimension of tension, mass 1 in mass, and here 1 in length minus 2 if you take here, mass per unit length if you take here, then what you are getting is 2 in length minus 2 in time. This is not the dimensional formula of velocity, right or not? Is it okay? Dimensional form, it is not the dimensional. That's the reason this equation, to make that dimensionally this equation correct, what we have final equation is root of tension divided by mass. This is actual velocity equation for transverse wave setting up in the stretched string. Now when I take the root of this, definitely here comes meter per second, here comes 1 in length minus 1 in time, right or not? Root of this is what the equation of velocity of the transverse wave.